Hello, I'm Li Hao. Welcome back to Evan of Code 2023. We are solving programming puzzles every day, and today we are on day 13. So, what is the puzzle on day 13? Let's take a look. Day 13, Point of Incidence. With your help, the Hot Springs team locates an appropriate spring which launches you neatly and precisely up to the edge of Lava Island. There's just one problem. You don't see any lava. You do see a lot of ash and igneous rock. There are even what look like grey mountains scattered around. After a while, you make your way to a nearby cluster of mountains only to discover that the valley between them is completely full with large mirrors. Most of the mirrors seems to be aligned in a consistent way. Perhaps you should head in that direction? As you move through the valley of mirrors, you find that several of them have fallen from the large metal frames, keeping them in place. The mirrors are extremely flat and shiny, and many of the fallen mirrors have lodged into ash at strange angles. Because of the terrain is all one color, it's hard to tell where it's safe to walk and where you're about to run into a mirror. You note down the pattern of ash and rocks that you see as you walk, which is your puzzle input. Perhaps be careful, and perhaps by carefully analyzing these patterns, you can figure out where the mirrors are. So for example, this is our puzzle. I guess this is one map, and this is another map. To find the reflections in each pattern, you need to find a perfect reflection across either horizontal line between two rows or across a vertical line between two columns. So in the first pattern, the reflection is across a vertical line between two columns. Arrows on each of the two columns point at the line between the columns. So I guess it's between column 5 and 6. So this is the reflection point. In this pattern, the line of reflection is the vertical line between column 5 and 6. Because the vertical line is not perfectly in the middle of the pattern, part of the pattern, column 1, right? So here I reflect 4, so the part of column 1 has nowhere to reflect onto and can be ignored. Each other column has a reflected column within the pattern and must match exactly. So column 2 match with column 9, column 3 match with column 8, 4 with 7, 5 and 6. Second pattern reflects across the horizontal line instead. So this is the mirror image, right? 4 to 5, 3 to 6, 2 to 7. This pattern reflects across the horizontal line between rows 4 and 5. Row 1 will reflect to a hypothetical row 8, but since that's not in the pattern, row 1 doesn't need to match anything. Remaining rows match 2 matches with 7, 3 matches with 6, 4 matches with 5. To summarize your pattern notes, add up the number of columns to the left of each vertical line of reflection. To that, add also 100 multiplied by the number of rows above horizontal line of reflection. In the above example, the first pattern of vertical has 5 columns to its left, right? So this is where it's reflected, 5 to its left. And the second pattern horizontal line has 4 rows above it. So this is where the reflection is. So we have 4 rows above. So 4 times number of rows, which is times 100. So the total is 400 plus 5, which is 405. 5 the number of lines in each patterns in your notes. What's the number you get after summarizing all your notes? So unfortunately, I recorded this question once and I forgot to hit record. So I talked through myself to the camera without recording, and I already have the puzzle answer, which is this. But I forgot to record, so I'm gonna record myself doing it again, and hopefully we get the same answer this time round. And I checked, it is recording. So let's start. Write our code. So here is our code editor. As you can see, all the puzzles and answers for every day is here, and I have left the code on GitHub, and the link to GitHub is on the description in below. So here, let's start our puzzle 1. So first thing is I'm going to create a input, and the input is going to be this one. Let's copy this and let's paste it in. Okay. And next thing I'm gonna do is we have a variable called answer, which starts with 0. And at the end of our code, we're gonna print out answer, which is our answer, and so we can see it and we can compare it with the actual answer that we get. So next thing is we're gonna parse our inputs. So first thing is I'm gonna split the lines input into every line, split by new line, right? And then I am going to have a variable called I, which tells us which line we are in. And I guess while I less than lines.length, so I'm gonna iterate through every line and I'm gonna parse out this, right? So this is one map, this is another map in the input. So we're gonna take out a map one by one, and then we're probably gonna summarize and solve that map, right? So first thing is I have a variable called starts line index equals to I, right? So we are at where I is, this is the starting line, and then we're gonna iterate through, we're gonna increment, we're gonna find the ending line over here, right? So while I less than lines.length and I not equals to empty line, I plus plus. And so this is where the end line index gonna be, right? So our map is basically start line index, lines dot slice, the start line index with the end line index, right? So this is our map, and we're gonna solve this. So we're gonna have a function called summarize, because they say summarize your pattern, right? Summarize map, and hopefully this returns the value, whether it's vertical or horizontal. And maybe for rows, then we're gonna have 100 multiplies by the number of rows. And if it's column, it returns the number of columns. So this, I'm gonna add it up with our answer, add it to our answer, and we continue a loop, right? So now I is in the line, in the row where which is the new line. The I is here. I'm gonna increment one more so that later on when our start index, this is pointing exactly where I is. So I will say I plus plus over here. All right, like this, and then this is our basic structure. And next thing we need to do is to implement this summarize function. Summarize with a map. I'm gonna find the reflection point. Okay. So next thing is we're gonna try one by one. We're gonna try vertical reflection first, and then we're gonna try horizontal reflection. Right. So for vertical reflection, we're gonna start from 1 to 9. Here we have 9 columns, right? So basically it starts from 1 to 9. I guess like we can only have reflection between 1 and 2, but not 0 and 1, right? We have 8 and 9, 7 and 8. We probably don't have reflection between 9 and like so-called 10, right? So we're gonna go through we're gonna iterate from 1 to 8, and then see whether the reflection is between 1 and 1 to 2, 2 to 3, like 8 to 9. Right, so for that, I'm gonna say let column equals to 1, and column less than map.length. So map the first row length, column plus plus. So this gives us from 1 to hopefully 8, because if the number of columns is 9, then I guess this is this gives us a 9, right? I guess we can say the number of columns equals to map 0.length, number of rows equals map.length. Right, so this is here. So we iterate from column 1 to 8, and then we're gonna check whether that column is the correct reflection. So how do we check? We're gonna go by row. We're gonna row by row and compare whether it's the correct reflection. So we're going to go for row from 0, row less than map a number of rows. And for every row, we're going to compare two cells, right? So the left and the right from the reflection, we're going to compare whether it's the same. So left and right. So the left, so we're going to have two variables. So let's left equals to, so for the left, it's going to be here, right? And right is here. So the left, the index of left is 4, right? 0, 1, 2, 3, 4. So if the column is 5, the length is actually 5 minus 1. So this is column minus 1. And then right is equals to column. And then the condition is left is greater than 0. And right is less than number of columns. Left minus minus and right plus plus. Okay. So here every iteration we have a left and right. Start like this, and then we go left, go to the left, right, go to the right, and then go all the way until we hit the condition. Right. So here, if left the map row left not equals to map row right, then we are going to say that this, if we find any cell that is not the same, which means it's not a correct reflection, then we need to continue to search for the right column of the reflection. So we're going to continue find reflection. So this is, we're going to continue this way, the outermost loop, right? So we're going to continue find the reflection. So this is how we find a column. I'm going to do the same thing as to finding the row, right? So here, I'm going to replace this with row. Oops. Let's say row. Oh, how do I? It's okay. I guess I'll just change one by one. So this is row. Right, go through number of rows. And this actually is going to be column. It's the other way around, right? Column, row, and column. And then for finding reflection for row and this one, we are actually going from comparing the top and the bottom, right? So this one I'm going to rename it to top. And this one I'm going to rename it to bottom. So top basically is if the row is starting from 1 number of rows, right? So if the top is equals to 4, then I guess the index is 0, 1, 2, 3, right? Correct. So top is equals to row minus 1, bottom is equals to row, and then top has a greater than this, and this is number of rows, and top minus minus, bottom minus plus, and then here the map top column compared to the bottom column. If it's not the same, then we find reflection, right? And actually after we find a reflection, if we manage to go finish this whole loop of comparison and we actually passes through, right? Then actually every cells is the same, then I guess here is where we can say return the column, right? This is where the answer for the column of reflection. And same thing for here. This is where I'm going to return row, but we multiply by 100, right? This is where the row is. And I guess that's a right. So this is where we find, right? If how we compare and see whether this is the correct reflection point, and if it's, as long as we find a cell that's not, then we continue to find the reflection, right? If we manage to compare everything and it's correct, then we return column. And same thing with the row. This is the comparison, and this is the, if we manage to go through this validation, then return the results, right? And I guess that's roughly it. So let's try and run and see whether we get the right answer. We get 1002. Hold on, this is not correct. 1002, something is wrong. Okay, hold on, let me see. Since this is incorrect, let's see where we got wrong. Right, so here first thing is we're gonna check whether the map is correct, whether we take out the correct map. Right, so the first map, oh, hold on. Ah, the map is incorrect. This one. So this should be lines I not equal to empty line. Okay, so let's run again. We get 405, which is correct, right? 405 is the answer for the sample example. So let's get the actual input. Wait, let me find where's the puzzle input. Let's copy this one. And let's paste it in. Let's run it. 35210, whether it's the same as what we got last time. Yes, 31210. Yes, so I mean, we got a gold star, although I got it already. So that's for part 1. So let's move on to part 2. So part 2, resume walking through the valley of mirrors and smack, run directly into one. Hopefully nobody was watching because that must have been pretty embarrassing. Upon closer inspection, you discover that every mirror has exactly one smudge. Exactly one dot or hash should be the opposite type. In each pattern, you will need to locate and fix the smudge that causes a different reflection line to be valid. So the old reflection line won't be necessarily continue being valid after the smudge is fixed. Here's the example again. So the first pattern, the smudge is in the top left corner. And the top left hash, this one, were a dot instead. So it will have a different horizontal line of reflection. With the smudge in the top left corner repaired, a new horizontal line reflection between row 3 and 4 now exists. Row 7 has now no corresponding reflected row, can be ignored, but 4 to 3, 2 to 5, and 6 to 1, right? And the second pattern, the smudge can be fixed by changing the fifth symbol of row 2 to something else, and now you have a different horizontal line of reflection between rows 1 and 2. Summarize your note as before, but instead of using a new different reflection line this time, right? In this example, the first pattern new horizontal line is 3, and above the second pattern the new horizontal line is 1 row above it. So 300 plus 100 is equals to 400. In each pattern, fix the smudge and find the different line of reflection. What number do you get after summarizing a new reflection line in each pattern of your notes? Right, so we need to solve this parts 2. So let's copy the code to part 2. Okay, let's come back and use back the example input. So this is back to the example again. Let's copy this one. Okay, let's reuse our code. I remember I left a console over here. Let's remove this first. Let's remove this. So this is the exact same code we used for puzzle 1. Now we need to figure out how we can figure out where is the smudge and find a new reflection line on top of it, right? So a naive way of thinking about this is to go and try to fix a smudge cell by cell, one by one, and then find whether is there a reflection point, right? If there's no reflection point, then that smudge is a wrong smudge fix, right? That's not the right smudge to fix. And go to the next cell and try to smudge it, right? So in this case, we will have to basically for maybe to find the reflection point, we have already iterated through this cell, right? By every row and every column, right? But then after, to fix a smudge, we have to go through every cell and smudge it and then compare again. Then I guess that's like a part of 2 of what we have done, number of times that we have done of what to fix the smudge, right? So that will probably take a very long time to actually do it. So the key here is to realize that actually you don't have to find where is the smudge. I mean, you might want to know where the smudge is, but actually we can reuse the whole code that we have, and then whenever we find a cell that is incorrect, then we assume that probably that is the smudge, right? So we record like how many times we run into something that is incorrect, and if the same code finding reflection, we run into ourselves that we find that that's like more than one time that's wrong, then I guess that's like too many smudges. Then I guess that's not the right reflection point, so we can skip it, right? So we keep counting how many errors that we run into, and if it's more than one, then that's not the right reflection point. But at the end of the whole iteration of finding reflection point, and you realize that there's exactly just one error, which exactly one smudge, then I guess that's the answer. That's where the reflection point is, right? So this is how I'm going to change the code. So for puzzle 2, when we find a reflection, whether it's column or vertical reflection or horizontal reflection, I'm going to initialize a variable called error count. So this counts number of errors that we have. And when you run into something that is wrong, let's assume that that's a smudge, right? So we have error count plus plus. But if this error count is already greater than 1, then I guess that's not the right, we have too many smudges, then that is not the right reflection point. We can skip ahead, we can find the next reflection, right? And at the end of it, at the end of finding, right, if only if error count is equals to 1, then this is what we want, right? We only have exactly one smudges, right? If it's 0, then we don't want. But it's greater than 0, we have already skipped ahead, we have continued find reflection. And let's make this same change for finding horizontal reflection as well. Let's count error count equals to 0. And then here, error count plus plus. And then if error count greater than 1, then we're going to continue our finding reflection. And at the end of the turn, if error count is exactly equals to 1, that is our answer, and we're going to return this answer instead. Right? So that's the change that we make for parts 2, and let's try and run our code and see whether we get the right answer now. So this gives us 400, which match exactly as the example, right? So now let's use the actual puzzle input. Let's come here and let's try to paste it in, right? And let's try run our code and get 31974, which is exactly as what I got previously. Yay! So now we have solved day 13. We got 2 gold stars and we are ready for day 14. So I shall see you in day 14. So see ya. Bye bye.